Hi everybody, this video is about plate tectonics, okay? This is what you were assigned on Wednesday for science, so I'm going to go over it a little bit with you guys in case there was any confusion. So it starts on page 390. I'm going to start reading, so follow along with me. You can see objects in motion all around you. Did you know the surface of the earth beneath your feet is in motion too? Earth's crust is a hard shell of rock, but is not one solid piece. Many pieces of crust called plates fit together like a jigsaw puzzle. The plates rest on the Earth's mantle. If Earth's mantle flows like warm plastic, do the plates move too? Yes, they do. The motion of Earth's plates is very slow, however, it happens too slowly to see. Okay, so it is like a jigsaw puzzle. If you look at the map below, it looks like all the pieces could kind of fit together. Okay, these are all the plates, as they call them, fit together. Okay, we have the North American plate, the Pacific plate, South American plate, with a bunch of different pieces of the puzzle that fit together. And like we talked about with the layers of the earth, the mantle is kind of like semi moist. It's semi liquid, so it's kind of got like a gluey feel to it, where it's not completely solid, but it's not completely liquid. So the plates move on top of that. Okay, or I should say the mantle is what moves the plates, okay? So the theory that Earth's crust is divided into plates that are always moving is called plate tectonics. Some plates contain mostly continental crust. Others contain mostly oceanic crust. Many plates are made up of a combination of the two. In some places, plates are moving toward each other. In other places, the plates are spreading apart. On page 391, there's some visuals. You could see all the way at the top. It looks like a satellite image. It says the Aleutian Island chain near Alaska formed where northern edge of the Pacific plate is pushing against the North American plate. So this is an example of two plates pushing towards each other. The other picture is the Great Rift Valley. The Great Rift Valley formed where the Arabian plate is splitting the African plate into two separate pieces. You could see there's all cracks in there, like as if it's been broken apart. Sometimes, if you break a pie apart, you could see the crust almost, it cracks. It's very similar to how the Earth's crust works. Okay, so look at the map at the plates that contain North America and Europe. Each year, North America and Europe are about 19 millimeters farther apart. Now that's very, very small. Millimeter is, I can't even do it with my fingers. It's so small. So 19 millimeters is maybe this big at the most a year. But still, that means they're moving. They're moving farther apart every year. Okay, that adds up after a lot of years. Certain land features form where plates collide. Other features form where plates separate. Mountain ranges, island chains, and enormous valleys are sometimes likely signs of a plate boundary. Okay, so if going back to what I was just talking about, North America and Europe, if you could see on the other page, here we are, North American plate and the Eurasian plate, they're moving apart from each other, okay? They're separating, like they said, 19 millimeters farther apart per year, okay? So going to the questions, what can you tell by comparing the shapes of the continents with the shapes of Earth's plates? A lot of the times, the continents add up with the Earth's plates. and then a lot of times they don't necessarily. For example, the North American plate, it has some land, but it also has some oceanic crust too, okay? But a lot of the times they do fit together like a puzzle piece. If you look at the continents, it looks like they were once formed to one, maybe one solid piece of land, okay? So moving on to plate boundaries, this means where one plate starts and one plate ends, kind of almost like we have political boundaries. We have a boundary outside of New Jersey. You know, on one side we have Pennsylvania, we have New York to our south. I'm sorry, I should say or north. So just like we have boundaries with states and countries, there's also boundaries within plates too, okay? And we're going to learn a little bit more about that. Plate motion, I'm on page 392. Plate motion may be too slow to see, but what do you think happens where two plates meet over hundreds or of thousands of years? The landforms we see today can give us clues. Tectonic plates move toward each other and spread apart. Plates also slide past each other. Different types of plate motion produce boundaries that shape different landforms. Continental plates moving towards each other push up mountains. So that makes sense. If something's pushing up towards each other and there's friction, has nowhere to go, it's going to go up, right? So it forms a mountain. When an oceanic plate moves towards another oceanic plate, one of them is pushed down under the other. So just like it could be pushed up like this, like a mountain, and an oceanic plate goes toward each other, usually one goes below the other one. So this collision can cause a deep ocean trench and an arc of volcanic islands to form. When an oceanic plate collides with a continental plate, the denser oceanic plate sinks under the continental plate, causing mountains and volcanoes to form along the boundary between the plates. When plates pull apart, new crust forms a ridge on both sides of the boundaries. Okay, so we have some visuals here on page 393. Starting from the top left over here, two plates can slide sideways past each other. Earthquakes occur often at these boundaries. At San Andreas Fault in California, the North American plate is moving southward and Pacific plate is moving northward. So this is a case of plates moving like this alongside of each other, parallel to each other, okay? And that's a lot of times that causes earthquakes. Okay, then going to the right, we see where plates are moving apart and they're pulling away from each other. So two plates can pull away from each other. On land, this forms a rift or separation. Iceland sits across the separating boundary between the North American plate and the Eurasian plate. It will eventually become two separate land masses. So if you see in the picture, these two plates broke apart, and now there's a big ridge or canyon in between them. The last one at the bottom, it says as two continental plates move together, their edges fold and bend, pushing up mountain ranges. The Himalaya range in Asia includes the world's highest mountain peaks. The Himalayas are still growing today, and as the Indo-Australian plate pushes against the Eurasian plate. Okay, so they're still getting even bigger. The Himalaya range is the biggest mountain range. And it includes the world's tallest mountains, but they're still getting bigger. Okay. Okay, so it says draw arrows on the diagram to show a kind of plate boundary. Then draw a landform that can occur at that kind of boundary. So it wants you to pick. You could pick the ones that are going like this, sideways, pulling apart, or pushing together. And then what landform would that make? remember, pushing together, it could be a mountain. If it's going sideways, it could create an earthquake. Just some ideas. Okay. Okay, so that is it for plate boundaries and plate tectonics. Next video will be about earthquakes. Thanks for watching.